How far away is that galaxy? Distance is one of the most important things we need to learn about any astronomical object. Many of the other conclusions we can draw about them depend on how far away they are, so measuring distances is crucial in astronomy. We've already practiced a couple of techniques for measuring distance, but this time we're going to try one that can only be used for distant galaxies. The Hubble law is a description of the expansion of the universe. For galaxies outside of the gravitational influence of our own Milky Way galaxy and its neighbors, we can use this expansion to estimate how far away they are. The greater the distance, the faster they move away from us. Since we can measure the speed, we can measure the distance. We're really trying to find two things here. Our main goal is to get the distances to some of the galaxies in our constellation. But to do that, we're going to have to find how fast they're moving away from us. All of this works because of an observation Edwin Hubble and his colleagues made in the first part of the 20th century. The farther away a galaxy is, the faster it moves away from us. The underlying cause of this is an expansion of the entire universe. Space itself is getting bigger over time. But to us, it just appears that on galactic scales, everything is moving away from us. As I said before, this only works for distant galaxies. When galaxies are too close together, then their gravity overcomes this expansion, so they don't move apart. They can even move towards each other, so we'll need to watch out for this effect as we calculate the distances. The question gives us one key piece of information we should record: the rest wavelength of the H-alpha line. This is a spectral line seen in many stars and galaxies. By comparing this wavelength with the wavelengths of the same lines seen in these galaxies, we can find out how fast they're moving away from us. The question is asking us to predict which galaxy is farthest away from us. We already know that this will be the galaxy that is moving away from us fastest. So now we need to decide which galaxy will be moving fastest. For this, we look at the Doppler shift. This is the change in wavelength of light caused by the motion of the thing emitting the light. When an object is moving towards us, its light is shifted to shorter wavelengths. We call this a blue shift, since blue is the short wavelength part of the visible spectrum. If an object is moving away from us, the light moves to longer wavelengths. This is called a red shift. So to make our prediction, we should look at the wavelengths of the H-alpha line observed in each of our galaxies, and use that to decide which galaxy has the largest redshift. That's the one that should be moving away from us fastest, and hence is farthest away. Remember to explain why you picked the galaxy you did. We need two equations to solve this problem: the Doppler shift formula and Hubble's law. Doppler shift is given by this formula. V here is the speed the galaxy is moving away from us. We have both lambda and lambda naught in this equation. Lambda is the wavelength of the spectral line we observe coming from the galaxy. Lambda naught is the wavelength of that same spectral line when we measure it in a lab here on Earth. Notice that lambda naught is the version on the bottom of the fraction. In principle, we could use any spectral line for this calculation, but the one we use most often is the H-alpha line, since it's usually easy to observe in galaxies. The c in this equation is the speed of light. Notice that the velocity of the galaxy will come out in the same units we use for the speed of light. It will be easiest if we give this speed in kilometers per second this time. This will save us a step in the calculations later on. The other equation is Hubble's law. Again, the v here is the speed of the galaxy away from us. D is the distance to the galaxy, while h naught is the Hubble constant, the constant that describes how fast the universe is expanding around us. You should look up the value of the Hubble constant. You can find it in either kilometers per second per megaparsec or kilometers per second per megalight year. You're welcome to use either one. Remember that mega here means million, so these are millions of parsecs or millions of light years. You'll also want to write down the speed of light in kilometers per second and the H-alpha wavelengths for the three galaxies you're calculating, including the one you predicted would be farthest. Note that we don't need to do any unit conversions here, so you can leave that box blank. Now we can calculate the velocity and distance to a galaxy. I'm going to work through an example with an observed H-alpha wavelength of 657.597 nanometers. Notice that this isn't much different from the H-alpha rest wavelength of 656.285 nanometers. Even a small change in wavelengths can mean the galaxy is moving away from us quite quickly. Let's put both the galaxy's wavelength and the rest wavelength in the Doppler shift formula, along with the speed of light. Again, notice that it's the rest wavelength that goes on the bottom of the fraction. Then divide the top and bottom of the fraction. This value is known as the redshift, and for any galaxy we're calculating here, the redshift will be much less than 1. If you get a number close to or larger than 1, it means you should go back and check your calculation. Also notice that the units in the fraction have all canceled out. Finally, we multiply this by the speed of light to get the speed the galaxy is moving away from us, 600 kilometers per second in this case. If you get a negative speed, that probably means that the wavelength from the galaxy is shorter than the rest wavelength. In that case, the galaxy is blue shifted instead of red shifted. This means it's probably a relatively close galaxy to us, and the expansion of the universe isn't pulling it away. So you won't be able to calculate a distance to this galaxy, and you should do a different one instead. The next step is to use Hubble's law to find out how far away the galaxy is. We can put the speed on the top of the fraction and the Hubble constant on the bottom. I'm using the Hubble constant in kilometers per second per mega light year. When we divide these, we find that the galaxy is about 27 mega light years away. That means 27 million light years away from us. So now you should see if your calculations match your predictions. If they do, then say so here. If the problem was with the prediction, you should discuss what you should have predicted and why. You should certainly be watching for possible calculation errors. If you're getting speeds larger than the speed of light, you know something is wrong with your answer. Also remember that the universe is only 14 billion years old, so we can't see galaxies that are more than 14 billion light years, or 14,000 megalight years away. If you get a distance greater or even close to this value, that suggests a problem. Finally, remember that these are galaxies, so they should be well outside of our own Milky Way galaxy. This means they should be at least 1 megalight year away, and probably a couple of times more than that to get them outside of our local group of galaxies. If there's a problem with the calculation, see if you can find it or ask for help. If you run out of time, at least comment on why you think there's a mistake.